Alright, been a little hiatus for a while, was on vacation, but I'm getting ready to do some major changes here on the ebulator. Well, the whole apparatus really. The ebulator is going to stay more or less the same for now. I have a few other videos on this. Check my channel. If you do a search for ebulator, E-B-U-L-L-A-T-O-R, kind of probably the only thing you're going to find in some of my videos. So, if you haven't watched any of the other ones, this is a refrigeration apparatus. I'm not going to go through all of it because there's quite a bit to explain, but got to do a little update before I start tearing things down. So the refrigerant in this thing is propane. Right now I'm running a York 210 compressor out of a automobile. Have a treadmill motor down there that powers this thing. Been typically running about probably 60 to 100 RPM, and having some issues with lubrication, I believe. I don't know how much oil I'm actually passing through the system, but I have done an oil check, a little dipstick down there, and there's still within factory, specs. But I don't think I'm getting enough lubrication with the low speed. It's a splash lubrication compressor, and there's a lot of squiggling that goes on, and I think it's metal on metal, and it's the actual piston inside the bore. It may be a design flaw with these things. I mean, I've heard they're noisy as it is, but I'm running at pretty low speed, so it's not really within what it was designed for. I may do some tests with adding more oil to it, but right now there's so many different features of this thing that are unusual. I mean, specifically the compressor and this ebulator. It's a gravity flooded propane evaporator. High pressure. It's pretty hot in here right now. I just opened everything up. So normally refrigerant would be filled to about this level. There's a sight glass right here, which is somewhere up towards these top coils. And I've had this box down to negative 36 degrees Fahrenheit according to this temperature probe. My refrigerant control being a valve down in there, it's a needle valve, which is kind of a misnomer because it doesn't actually have a needle in it. It's more of a flat piece of machined steel. It's like cylindrical shape, and I have this little rod that I made that goes up through the insulation so I can adjust it without having to open up the box. The most recent test I did the other day, previously I designed these things to be round cylinders like this one because it was easy to add a lot of surface area, and the other reason was I was just going to throw some water bottles or something in here, some half-liter water bottles, and it's not enough heat conduction, and even lowering the temperature inside the box, after a long period of time, I mean, they're going to start freezing, and I've had some slushiness going on, but I don't like to run this thing for that long period of time. I mean, I would have to almost let it run for a few hours, and I don't trust my compressor enough to run it for that period of time, and my motor doesn't have any cooling, so it gets pretty hot. So what I did recently, just for shits and giggles, I thought it would be cool to actually be able to get some direct heat conduction from the water source to the evaporator coils to cool them. And what I'm eventually going to do is build really a direct freezing system, a plate system. Has some aluminum plate on some coils. They're going to be a flat coil, and make some probably half-inch thick ice plates. But in the meantime, I thought, well, I might as well play with this thing as much as I can. There's a lot of copper and a lot of work involved in this thing. So I got some. I was going to get some copper mesh, copper scrubbers to use for. I guess you use them for like copper pots or anything you don't want to use steel wool on. Had trouble finding any, and I decided, well, screw it. I have a big bag of steel wool at home, so just give it a shot. Steel's not going to be anywhere close to the conduction of what copper is, but screw it. I have a lot of it. I'll just stuff it in there and stuff some of these cans in. There's one that was just a control with no stainless steel, or excuse me, no steel wool, and I just shoved them in around that. And my one fear was that it was actually going to kind of act as an insulator and not conduct much heat, and I actually happened to be right, I think. It didn't work particularly well because the control, which I was hoping wasn't going to cool down as fast, actually cooled down quite a bit faster. This is aluminum or excuse me, stainless steel cup. But anyway, yeah, it kind of acted like an insulator. So anyway, I just kind of ditched that whole thing because ultimately I want to redesign the entire ebulator system, and it's going to be pretty involved. So until then, I thought, well, I want to play with this a little more, and since I can't run this thing for too long or too late in the evening, I live in a trailer park here after all, makes a little bit of noise, makes a lot of noise, I thought, well, it's time to just get a Hermetic compressor. So I acquired a exhausted air conditioner. It's not very old, rotary type compressor, R22 refrigerant, 5,000 BTU per hour rating on the air conditioner. I think total consumption is like rated at like 500 to 550 watts. I think I read somewhere this is like a third to a half horsepower, 7.5 cubic centimeters per revolution. I'm not exactly sure what the speed is on it, so I'll get some more of those specs here. But anyway, good enough for my purposes. So what I'm going to do, at least start prepping after I finish this video, is I'm going to take this compressor out. I'm going to install some service valves on the Hermetic compressor, because this has service valves on it, and well, I just want service valves. I could just put ports on it so I could use my gauges. I'm going to need gauges, but so if I'm going to do it, I might as well do it at least half right and put some service valves on it, and then make some kind of a mount so I can continue to use these more or less the same position on these suction and the discharge off the compressor, so that if I want to, it can take me half an hour to just swap this compressor back in if I want to continue playing with it. When I want to continue playing with it, I am going to go back to this compressor. I'm not abandoning it. I have too much time and money invested into it, and this whole this whole rig. But in the short term, I want to be able to compare the Hermetic, and which isn't exactly a fair comparison. There's a lot of, I mean, rotary. Piston positive displacement, and then there's the speed. The displacement is different. This thing is surely going to superheat the hell out of the suction gas coming in. There's a ton of things. I think in terms of displacement, I think I would have to run this thing at 200 or 300 RPM or something like that to get closer to displacement. I'm not sure. I just did some rough calculations. I forget exactly. So I mean, there's a lot of differences, but nonetheless, it will be interesting to test this rig right here with that, and to run it for an extended period of time, because there's just too many factors to keep track of, and I don't have any data collection right now other than just some simple thermocouples there on a display, and I don't even really trust those too much. I am going to get some thermocouples that are inserted directly into the gas stream and or liquid stream. So anyway, that's enough for now, and once I get the thing rigged up with the new compressor, I will continue.